Okay, thank you everyone for joining us today, and we're going to talk about testing application code today. There's a construction since today outside of the house, so I hope this is not too loud for now, but I think it will be fine. Okay, so we're going to talk about specifically what testing code actually means, why testing code is important, and two different levels of testing that you can apply to your applications. And then during the second part, we're going to talk about how to write unit tests with Jest. And then after the 15-minute break, we'll talk about how to solve the exercises. Okay, so every time we write code, it's normal that we don't spot all the typos or edge cases that will cause bugs occurring on the end user side. So especially when you're changing existing code that you haven't worked with before, it is near to impossible to know every scenario the code has to handle. And in order to make refactoring easier and to prevent user-facing bugs, the code can be tested with testing tools to make sure that the erroneous parts are reduced to a minimum. And this can be done by testing bits and pieces of the code or testing the entire stack. So when testing the smallest parts of the code, for example, functions and classes, the test makes sure that for a given input or state, the function or class will return an expected value, or that React components render expected HTML. Testing entire apps will ensure that the app works in the intended way, while not testing any code directly. Tools that help testing apps open a browser and click or type just as a user would do. And of course, apps and code should be tested manually, but that's a cumbersome and time-consuming task. And without a dedicated team, manual testing is quite unreliable, and that's why tools can be used to automate these tasks, adding robustness to the app while reducing the burden on the quality assurance team. Okay, so why is testing important? Writing tests does take more time than simply writing the code, which is why it's often seen as a hurdle, but it offers several benefits that make adding tests worthwhile. By covering the app and code with tests, the amount of user-facing bugs and the time to confirm and fix bugs is reduced. And additionally, the time it takes to get back into the development flow is reduced as well, as developers don't have to handle unexpected issues. This is especially true for apps that are going to be used by DHIS2 instances, as what's normally being handled as critical health-related information. Testing apps can make a difference in data collection and display, so covering apps by both core developers and third-party developers is a very important yet overlooked aspect. At DHIS2, this has been a topic that we have not addressed properly for way too long. And roughly a year ago, we started adding tests to our applications and libraries, and we see and appreciate all the benefits this adds to our daily routine. It just feels a lot safer to work on apps, as we know that all the functionality that we covered with tests just stays intact. No, wait. One back. Additionally to just covering code with tests, after the code has been written, there are several alternative approaches. One of these is called test-driven development, or just TDD. And this means that tests are being written before the actual code, which adds the benefit that the developer has to think about the final structure and logic before writing code that she or he has to change eventually again while making up the structure on the go. Okay, so as mentioned, there are different levels of an app that can be tested. One of these is called end-to-end tests. We'll go through what end-to-end tests are and what tools we use at DHIS2 to implement these tests. Okay, so end-to-end tests don't test actual code, as mentioned. They instead try to test the entire product from beginning to end to ensure the application flow behaves as expected. In other words, an application is tested from one end to the other, which of course includes the user's perspective. The tool that we use at DHIS2 is called Cypress. We will not cover how to use Cypress during this workshop, but I want to give you a quick overview over the software so you can look into it yourself if you're interested. Cypress is a CLI tool with a graphical user interface for development. It opens an app inside the browser and just clicks or types on elements that a user would interact with. Between the interaction steps, the software performs checks to test whether an interaction has caused the app to perform a desired change. And with the graphical interface, every step of the test can be inspected, and this includes the DOM and the developer tools, DOM Explorer as well. So this is quite handy when developing tests, as it's easy to see why it's failing. So here you can see the graphical user interface, which will show all the available tests. Yeah, and here in the upper right corner, you can choose which browser you want to use for testing. We are using the default browser called Electron, which just uses Chromium under the hood. And here on this image, you can see some of the tests that we use to test our UI library components, like the alert bar or button. On this screenshot, you can see the test for the transfer component being executed. We are testing one specific feature here, which is allowing the user to highlight options, which you can see here, with key combinations like clicking with Control, Command, or Shift. In the center, you can see the actual component that's being tested. On the right-hand side are the developer tools, which mean they can be used to inspect the current state of the HTML at any state of the test. This allows to write tests relatively quickly and comfortably. If one of the tests fails, Cypress will provide details about what went wrong, and it will let you know about the origin of the error. It might come from the application itself or from the test code. In case an error occurs, you can see the console output and inspect the DOM at the time the error occurred. And this is what makes Cypress such a powerful tool and is one of many reasons why we will increase the test coverage of our apps with Cypress and our own CLI utilities. The test that you just saw in the previous screenshot is described in this file, which is a so-called feature file, which is divided into multiple scenarios. And you can see this is more or less normal English, which is another advantage of using these type of tests, as even non-developers are able to read what the software should be capable of. If this is interesting to you, I have included a couple of links in the README that I will share later with you. If you want to get started with Cypress while waiting until we have released a stable version of our Cypress utility tool. So in the future, we will provide utilities so you can use Cypress the same way we do. And these will include utilities to test DHIS2 specific logic and automatically comes with support for the feature files that you just saw. You don't have to use them though if you don't want to. Yeah, so just like I said, these are specific format to describe the specifications of the software in the natural language like English, for example. But this tool is currently in development and heavy to subject change. Sorry. Yeah, it will change a lot. So if you decide to use it with caution, as things most likely will change. Another way of testing code is to test the smallest parts of the code. And this is what we will have a look at today and what the exercises later will be about. As mentioned in the introduction, with unit tests, we can test the smallest units of the code, like functions or classes and their methods. These are very lightweight tests, so it takes a fairly low amount of time to run these. And this allows us to integrate these tests into our daily workflow, like in the pre-commit hook, which ensures that code that doesn't pass tests can't be added to the code base. This is especially useful when changing existing code. If the changed code will produce an unwanted behavior in a part of our code that hasn't been touched, this might be caught with these tests before it ever makes it into production code. And Michael Lynch says in his blog post that about why good developers write bad tests, that a good unit test is often small enough that a developer can conceptualize all the logic at once, which means these tests should really be very small and just about one particular part of the code. A very common tool to write these tests is called Jest, and it's developed and maintained by Facebook's developers and contains a complete package to write unit tests for JavaScript projects. It's so widely used that for functionality that's missing or just not covered by Jest itself, like for example, testing React components, there's a solution that will definitely cover the missing part. Like Enzyme, for example, which is a React component testing library developed by Airbnb. So Jest allows you to run tests in your terminal, which is way faster than using Cypress. In the screenshot, you can see that 164 tests were executed in just 4 seconds, which is quite fast. And when a test fails, Jest will tell you what exactly went wrong as well. In this case, the test expected only valid emails to be passed to the email validator function. And the description associated with this test's state should return undefined for value I am not a valid email address. Obviously, I am not a valid email address is not a valid email address, so this test fails for a very good reason. Here you can see the expected value is undefined, but it actually received an error message here. And Jest also caches its results. So if a test and all its related files have not changed, it treats the test as having passed, which is why it only took a bit more than 6 seconds to run all these 487 tests. Okay, so if you have any questions, feel free to ask them now. After the break, we're going to cover how to use this particular tool. Are there any questions?
You use Jest for integration testing as well?
It depends on, well, this is a funny topic. It depends on what you mean by integration testing. Integration testing, to me, means it's a compound of many units or some units. So it could be considered a unit test as well, and you can use Jest for this as well.
Okay.
We're not using Jest for functional or end-to-end tests.
Okay, thanks.
Any other questions? No? Okay. Then we can now have the 5 minutes break. I would like to remind you to please install the Chrome or Chromium browser, because unfortunately Code Sandbox doesn't work well with Firefox. You need to have these browsers ready when we do the exercises, not during the next 20-minute session. And if this is not possible for you for any reason, please feel free to contact us on Slack in the technical support channel.